delighted to speak to you today about the work we've been doing with local authorities to reduce roadside nitrogen dioxide or NO2 levels. I'll start my presentation by giving a bit of background about the importance of air quality. I will then give an overview of how JACU identifies NO2 hotspot areas and works with local authorities to develop and implement nitrogen dioxide reduction plans. I will go on to discuss some of the interventions JACU has funded and our evaluation approach to assess whether interventions have indeed worked. And finally, I will briefly touch on next steps. So, why do we care? Air pollution is a big deal. It's the largest environmental health risk with a huge impact on human health. COMIEP has estimated that the impact of air pollution in the UK is equivalent to between 28,000 and 36,000 deaths per year. It also comes with a significant economic cost. Public Health England has estimated the cost of air pollution, here PM 2.5 and NO2 together, in England to health and social care services could reach 5.3 billion by 2035. And whilst air pollution is an improving picture, you can see on this graph here on the right, it shows a significant reduction in emissions of all major air pollutants since 1970 to 2019. There is still more to be done. Specifically, the UK is failing to meet its statutory limit on annual average roadside concentrations of NO2. And this failure has been the subject to ongoing EU infraction and several High Court judicial reviews. The court has ordered the UK government to address all exceedances of NO2 limit values in the shortest possible time, and JACU was formed specifically to do that. So, how do we know what the problem is? And this is where the National Compliance Assessment comes in. This is based on a combination of monitoring and national modelling. So we use high quality AURN, which stands for the Automatic Urban and Rural Network Monitoring Stations, and we supplement this with our National Pollution Climate Mapping or PCM model. And in addition, for the first time this year, we have included results from the new UK Urban NO2 Network or UUNN, which is a new network of enhanced diffusion tubes. And all three of these data sources come together in a way which is consistent with the air quality standard regulations to create the annual compliance report for the UK. The annual compliance report is published every September and is available on the UK Air website. The compliance assessment really helps us show and visualise the scale of the challenge. So the UK is divided into 43 zones for reporting purposes with NO2 limits. If any area or road link within that zone exceeds the limit value, which is 40 micrograms per metre cubed, then that whole zone is deemed non-compliant or in exceedance. So in 2019, you can see the map on the left shows a map of all of our modelled roads. So we model over 10,000 kilometres of urban roads, and we assess whether or not they are compliant or in exceedance with the limit value of 40 micrograms. And in 2019, approximately 6% of our modelled road links were in exceedance. And these are focused around urban centres. Now, the translation of this 6% of road links means that 33 out of 43 zones were deemed non-compliant, and that's shown in the map in the middle by the red areas. In contrast, the latest assessment, which is for 2020, shows that only 5 road links, zones were non-compliant. But bearing in mind that 2020 was a rather exceptional year due to COVID lockdowns, and during those lockdowns there was an approximate 60% reduction in road traffic, this still demonstrates that there is a significant challenge to reduce NO2 roadside concentrations to legal levels. So, how are we going to go about achieving this? As I've said, our National Compliance Assessment identifies the areas of exceedance and identifies the local authorities with high levels of NO2. However, our PCM model, the national model, lacks the granularity needed to assess in detail the impacts of local schemes. So we fund local authorities to build their own more detailed traffic and air quality NO2 models that cover their local area specifically. Local plans must set out the steps that need to be taken to achieve compliance as quickly as possible, and they must also feature a charging clean air zone as a benchmark. And if they can identify measures that will bring forward compliance in the same time that a clean air zone would achieve this, then those alternative measures can be preferred. For completeness, the Mayor of London is responsible for air quality in the capital, and National Highways is responsible for air quality on the strategic road network. We know from our modelling that the majority of NOx emissions at the roadside come from road transport. So 70% comes from road transport, with diesel vehicles the largest source. Hence, we work with local authorities to support them to develop detailed local transport and air quality models of their local area. And we use these to create bespoke plans which will work in their area. We recognise no two areas are the same, and each benefit from a tailored solution, which often feature a suite of air quality interventions. So, for example, this could include a mixture of bus retrofit, traffic signal optimisation, speed limits, a charging clean air zone, or specific exemptions. These NO2 reduction plans are very detailed. Here, to try and show this, I've provided screenshots of the contents pages of the Bath and North East Somerset air quality plan to help express this. As in addition, these plans are subject to a very comprehensive evidence assurance process, which includes detailed review by independent technical experts. Ultimately, the aim of these plans is to create an outcome which will work in the real world, and we've adjusted our guidance as our knowledge has evolved or new challenges such as COVID have emerged. Now, I've mentioned clean air zones, but what are clean air zones? In a clean air zone, more polluting vehicles are subject to a charge. The aim of this is to help accelerate fleet turnover, encouraging the use of newer, cleaner, less polluting vehicles, but also to try and support a behavioural change, such as modal shift towards active travel or public transport, for example. There are 4 types of CASs. They range from a CAS A to a CAS D. CAS A charges buses, coaches, taxis and private hire vehicles which don't meet minimum standards. As the CAS class increases from an A to a D, so more vehicle types are included. So, for example, a CAS B also includes HGVs, a CAS C in addition includes vans and minibuses, and a CAS D includes private cars. As you can imagine, there's a significant infrastructure needed to support an operational clean air zone. For example, a vehicle checker has been created so that people, drivers, fleet operators can check if their vehicle is subject to a charge, and a network of ANPR cameras are established to identify vehicles as they pass or enter through a zone. Now, I've mentioned that every local authority plan is bespoke and tailored to their own specific situation. And one of the reasons why I really love working in JACU is that no two areas are alike, and it's a real example of working at a science policy interface. There is significant political challenge around these plans, and local authority plans vary very much in terms of scale and ambition. And you can see here on this slide some examples of quite powerful views set out very much. Some of them are pro-air quality improvements, and some of them are very strongly against charging. So it's a very dynamic and politically charged working area. The first clean air zone in England, which was launched outside of London, was launched in Bath in March this year. And between its launch on the 15th of March and September, there have been approximately 33,000 vehicles entering the CAS each day and 6.2 million in total, which aligns with what was expected. Of these, about 2.6% of vehicle journeys have been subject to a charge. Of the total vehicle journeys into or within this CAS, 4.5 million are made by cars. Now, as Bath's Clean Air Zone is a CAS C, cars are not subject to a charge unless they are operating as a taxi or private hire vehicle. The next largest group of vehicles were light goods vehicles, which are chargeable, and these represent approximately 550,000 vehicles, or 26% of all journeys. Following the launch of Bath's CAS, Birmingham went live with their CAS on the 1st of June this year. Birmingham's CAS is a CAS D, which means this also includes charging private cars. In Birmingham, between its launch on the 1st of June and September 21, there have been approximately 100,000 vehicles entering the CAS each day, and 8.8 million in total, which also aligns with what we were expecting. Of these, approximately 13% of vehicle journeys were subject to a CAS charge. Of the vehicle journeys into or within the CAS, 12% were made by cars. The next largest group were vans or light goods vehicles. What I think is interesting, and as expected, is vehicles subject to a charge in both Bath and Birmingham have decreased every month since launch. And this intelligence of what's actually happened on the ground is really, really valuable, because one of the things that we're really interested in is to actually understand, did it work? Are the interventions doing what they were expecting? And that's why we have a strong focus on the evaluation of our plans. We have a large central evaluation project which is run by Ipsos Mori with support of the Institute of Transport Studies. And the evaluation comprises of 3 main strands of activity which collectively will address our evaluation questions. Firstly, we're interested in before and after methodology, so we use ongoing monitoring and analysis of air quality and traffic data to focus on trends on NO2 and other key pollutants, traffic volumes and traffic compositions, and assess this against baselines. We also have rapid assessment case studies which complement the statistical trend analysis and offer short-term focused, targeted areas of work of items of a particular interest within a local plan, for example. Or we can go for more detailed, comprehensive, deep dive case studies which go further and involve a wider and more in-depth exploration of whether and how the full range of measures implemented are affected NO2 concentrations. And this can include surveys which include the influence of the behaviour of people and businesses. Now, as I've said, we really want to understand and use evidence to demonstrate if interventions have actually worked. Many of the interventions we've funded are expected to actually have quite a small improvement in total NO2 levels, and these could quite easily be hidden within air quality monitoring values, which by their nature are quite noisy. You can see the monitoring results in the blue squiggly line on the left here. And these can be quite easily influenced by other factors such as weather. So to try and drill down and solve this problem, we've developed through our evaluation programme some tools such as the EQ Eval tool. This tool is an open source R software package which de-weathers and de-seasonalises data, so we hope to be able to assess both general trends and change points within the data set. So what next? More CASs are in the pipeline, and the next CAS due to go go live is Portsmouth, due later this year. JACU has been working with 67 local authorities, and only 5 local authorities remain in the development phase of their NO2 reduction plans. So the focus of our work will naturally start to transition from development of plans to implementation of plans, with a very heavy focus on evaluation of success and learning from not just what went right but also what went wrong, and adjusting our policy approach as necessary. In this presentation, I've touched on the work that Bath and Birmingham have both done to improve NO2 in their areas. Both have developed really neat web pages, Breathe and Brum Breathes, which are well worth visiting. I hope the work that we've been doing helps generate a greater public awareness of the importance of air pollution, and ultimately delivers the changes we need to make the UK a better and healthier place to live. So thank you for listening, and if you would like to contact me, my email address is on the screen. Thank you.
Justine, thank you very much for that interesting presentation. I'm not sure whether there are any questions being posted from the audience. So in the meantime, let me use Chairman's prerogative to ask you, if you don't mind, a few questions myself.
Of course.
You talked about the charging of vehicles entering into these zones, but do you ever foresee a situation where vehicles would be outrightly banned from entering these areas if companies decide that paying the fee is something that they're willing to do?
That's a very good question. I think about whether or not banning a vehicle or making it subject to a charge is the correct way. And with our guidance, as I've mentioned, we ask local authorities to consider charging. So far, local authorities, some of them have considered banning a certain class or category of vehicle, but have decided against it. So at the moment, that hasn't actually been a sort of. There have been other considerations, such as bus gates, which do sort of restrict certain sorts of vehicles, but it's very much a kind of local authority prerogative onto which particular set of measures will work best within their local areas, and my team works with them to help support the technical evaluation of those.
Yeah, thanks very much for that. Yeah, you also, from a monitoring point of view, and I'm a monitoring guy, so you mentioned that the data from the monitoring networks can be noisy. In other words, there's a lot of local and background pollution. Weather conspires against us in CASs. I know when the LEZ in London, or the ULEZ in London, came in, which actually meant that the pollution went up in the first few days of the action. So have you considered the possibility of trying to separate the local and regional signals so that we can understand more effectively the benefits that the CAS may be having on the local? Because it's very difficult, of course, to peel that away from the total observed concentration in the network. Is there any work going on in DEFRA for to try and address that issue?
Yes, I mean, as you say, trying to actually make sense of these monitoring signals is absolutely paramount. We're very much aware that these kind of bigger is we really need to get a handle on that. So I hope in my presentation I spoke about some of those tools that we're trying to make a sort of the best understanding we have of a time altering background signal, so we can try and subtract that from the monitoring data that we get. So for each site, as part of our central evaluation work, we have tried to control match for similar locations outside. Of course, that is a little bit tricky with JACU because in effect we're working with an awful lot of areas of the UK, but to try and attempt to get that kind of control so that we can look at the background. I think sort of thinking about it slightly wider in terms of monitoring, that's why we're being the metadata behind our monitoring, behind the monitoring that we're collecting. So not just sort of technical aspects of what sorts of sensors are being used, but really being quite tight on sensor location in sort of specific sites, as in we're trying to pick locations which are away from air quality concentration hotspots. But yes, we're very much aware that this is a big challenge, and that's why we're developing to try and disentangle that kind of sort of background significant influence to our monitoring signals.
Yeah, thank you. I agree. It's a very difficult thing to address, but it sounds like you're on the case. Finally, I think a lot of the audience will have picked up on the facts that I think it was in Bath, only 2.6% of the vehicles entering the city are liable for charge, if I picked that up correctly. And in Birmingham, it's 13%. Is it perhaps it's a little bit early, but is there any evidence to show a correlation between the percentage of vehicles being charged and the improvements in the air quality? I know it's extremely early in the process, but is there any indication there?
At the moment, I would say it's too early to tell. I think we have to be quite mindful that we need to collect a sufficient body of data to be able to sort of robustly answer that question. That is something that we're looking at. I think the percentages are quite different between the two cities, but of course they've got different sorts of CASs. So within a CASD, for example, we're also looking at private cars as being subject to a charge. So I think that sort of really does sort of change some of the numbers of vehicles that we're looking at that come within scope of the CAS charging between the two areas.
Absolutely. Well, again, Justine, thank you very much for the presentation. I found it incredibly interesting. I'm sure everyone else did too. At this point.